So today we're going to look at how to find the volume of right cones and right pyramids. Now I have included here two diagrams of a cylinder and how a cone relates to a cylinder. We know that for a cylinder we always will have a perpendicular height, and we also will have a radius that is useful in here. The volume of a cylinder is just going to be the area of your base, so a circle pi r squared times by your perpendicular height. So we know that as a fact. Now for a cone, ultimately, if we have a cone, we can have the exact same base and have it sit directly inside of a cylinder. It's going to have exactly the same radius, and it's going to have the same perpendicular height. The difference is, going from a cylinder to a cone, the volume is actually nicely 1/3 the volume of the corresponding cylinder. So the area of your base, pi r squared, times by your perpendicular height. So a cone versus a cylinder, the only difference, and this is kind of important just to identify that, is that it is 1/3 of the volume. So same thing goes if we have a prism, in this case a rectangular base prism. We know that we can have, in this case, the area of your base, which would be the length times the width, again times the perpendicular height. So if this is our perpendicular height, length, and our width, we know our volume is going to be length times width times your height, which is perpendicular. If we were to draw a pyramid in here, again we take the center point of the top plane, and it'll drop back to that little point back there. It would have the exact same base, and then you'd have a little pyramid. So in this case here, it has still, again, the same perpendicular height, same length, same width, and the volume for this one, again, is going to be 1/3 of your length by your width by your perpendicular height. So again, it is 1/3. So the main difference is that you recognize that when we're working with the formulas. So now if we look at an example of a volume of a cone with a diameter 20 centimeters and a perpendicular height of 4 centimeters, we can sketch this so we have our cone and we can fill in the details that we require. Now since it has a diameter of 20 centimeters, that means we have a radius of 10 centimeters. It has a perpendicular height of 4 centimeters. The diagram's not quite to scale, but that's okay. Like so. So if we ask to find the volume of it, we can write it as 1/3, because we're working with a cone, your area of your base, which is pi r squared, pi 10 squared, times by your perpendicular height of 4. So you're going to have 100 times 4, so 400 over 3 pi, and in this case centimeters cubed. If you want to actually evaluate that out, by all means you can, and then you can get the decimal approximation for this problem.